Start recording. Hi friends, myself Dr. Jairamaya JR, Assistant Professor of Physics, Government First Grade College, Tiptur. The title of the paper is Quantum Mechanics 1. For BSc Physics 5th semester, the today's session is numerical problem. Today's session, the objective of the session is to enhance the cognitive ability of the perception. Session outcomes: skill ability, thought provoking. To start to discuss some numerical problems on the previous sessions. The first problem: discuss that Compton effect is not observed for visible light. So we know that Compton effect formula is change in the wavelength delta lambda is equal to h upon m naught c into 1 minus cos theta. So that is delta lambda is equal to h upon m naught c into 1 minus cos theta. Here theta is the scattering angle. If theta scattering angle is 180 degree, the scattering is maximum. Then the values are substituted. H value is a Planck constant is 6.623 into 10 to the power of minus 34. M naught is the rest mass of the electron, and C is velocity of light is 3 into 10 to the power of 8, and 1 minus cos theta is scattering angle is 180 degree, so that is the maximum. Cos 180 is minus 1, so that is 1 of minus 1 is 2. Then simplify, we get the value, the Compton shift or change in the wavelength is 4.8 into 10 to the power of minus 9 meter. So the obtained value after calculating the value, change in the wavelength delta lambda equals 4.8 into 10 to the power of minus 9 meter. So this wavelength is a very shorter wavelength, so this is not the visible light. The calculated wavelength is in the range of X-rays. Hence, in a Compton scattering, we are not able to observe the light because the wavelength of visible light is very much higher than the observed value. That's all. Second problem, the cutoff wavelength of a metal is lambda is equal to 450 nanometer, and it illuminated with a wavelength of light lambda is equal to 400 nanometer. Find the maximum kinetic energy of ejected electrons. For illumination wavelength is less than the cutoff wavelength, eject the electron. So then the energy is h nu is equal to is equal to work function is equal to, we are hf is nothing but hc by lambda minus 5. Then energy E is equal to hc into 1 minus incident wavelength minus of 1 upon cutoff wavelength. So these values are substituted and simplify, we get the value, energy value obtained is 0.344 electron volt. So this is like this. Another problem, the wavelength of light 0.6 micrometer falls on a photocell, and the emission electron with the stopping potential is 0.5 volts. The wavelength of light is 0.4 micrometer with the stopping potential is 1.5 volt. Then calculate the H by E. So this is the numerical problem. Here The energy EV is equal to Hc upon lambda minus work function. So this is the mathematical relation regarding the photoelectric effect. Energy is equal to Hc by lambda minus work function. So this is the formula for the photoelectric effect. Then V is equal to this V is equal to Hc by E into lambda minus work function divided by E. So by rearranging this equation, we get the relation like this. Then substitute the values for V is equal to 1.5 minus 0.5, then Sc by E minus 1 by 4 minus 1 by 6. Substitute the values and simplify. Then the H by value is obtained is 4 into 10 to the power of minus 15 volt second. Like this, we are going to solve this numerical problem. Similarly, in this regard, some numerical problems are corrected by the textbook and solve it. Get some references textbooks are A.K. Upadhyaya, I.K. International Publishing House. Another textbook is R. Murugesan, S. Chan and Company. So, thank you very much.